All right, my name is Paul Megan. I work on Amazon S3. I'm here to talk about what's new with our service. I'm going to cover 10 features today, sort of my top 10 from all the stuff that we've launched, basically since we were all last here together at reInvent in 2018. Okay? My talk is a 200 level talk because of the breadth. It's sort of 10 features, so I may kind of skip across the top on some of the stuff, but if there are any questions, if you need pointers to resources to help you dive deeper here for the remainder of the show or after when you go home, come ask me questions afterwards. I'll stay till all of your questions are answered, and I'll make sure you get pointed in the right direction so that you get the level of depth that you need to go back and do your work back home. Okay? My talk is divided into 3 sections. I'm going to talk about cost reduction. I'm going to talk about security and access and some of the cool stuff that we've launched here in the show in that category. And I'm going to talk about data management, so how to manage and work with millions or billions of objects once they're already landed in S3. Okay, so those are sort of my 3 mini talks, and again, spread across 10 new features in S3. So the first thing that I'm going to talk about is cost reduction. And it's very common for us when we talk about cost reduction with customers, the vehicle by which we deliver that cost reduction comes in the form of storage classes. And if you've seen a presentation from the S3 team lately, you've probably seen some derivative of this slide here. This is sort of a high-level view of our storage class portfolio as it exists today. We have 6 storage classes in the service. 2 of them in particular are new and have been introduced over the course of the last 12 months or so. And so I'm going to dive deeper into those 2, which are Intelligent Tiering and Glacier Deep Archive. And these 2 storage classes are 2 of our most popular storage classes. Customers have adopted them very quickly since they were released. And I think the reason why is because they both kind of introduce fundamental changes into the way that we think about storing data in the cloud, especially with regards to how we tier across multiple classes within S3. S3 Intelligent Tiering, which we launched at reInvent last year, fundamentally changes the way that we think about managing data across tiers. It cost optimizes automatically on your behalf instead of you having to do anything to think about which storage class makes sense for any given object. Glacier Deep Archive, on the other hand, it fundamentally changes the economics of cloud storage. It comes with a storage price that is so low that it changes the math when customers are evaluating what to store in cloud storage and for how long to retain it. So I'm going to dive deeper into each one of these now and give you a little bit more detail on how they work and what they are, starting with Glacier Deep Archive. So Glacier Deep Archive, like I mentioned, comes with a very low storage price. It costs less than $1 per terabyte per month. Now, I've been working on storage for a long time. I've been coming to Vegas for like 12 years to talk about storage. And so I'm used to the declining per gigabyte storage price thing. But this price that comes with Glacier Deep Archive just makes me feel old, right? It's very low price. It's so low that it gets down into the range of tape when you kind of start to compare economics against alternatives. So it's comparable to tape in terms of the economics of Deep Archive, but the big difference between tape and Glacier Deep Archive is that with Glacier Deep Archive, you don't have to manage tape, right? You don't have to manage cartridges or robots or labeling or getting all of that stuff out of the robot onto the truck and into a vault offsite. It's entirely operated through the S3 API. And on top of that sort of much smaller burden to manage it, you also get the 11 nines of durability that come with any S3 storage class, and you get the ability to recall your data from asynchronous storage within 12 hours, which, if you compare to a tape in a third-party vault off-site, is actually pretty darn quick. There are 3 differences, or 3 principal differences, between Glacier and Glacier Deep Archive. Customers have asked many times over the course of the last year as they've evaluated this new storage class, kind of what is the difference and how do I decide? And this is really kind of the foundation for much of the decision criteria that you face Those three differences are the price is different. Glacier Deep Archive is significantly cheaper than Glacier. The data retrieval times are different. So with Glacier, you have the option to do an expedited recall and get your data back in minutes, whereas with Glacier Deep Archive, your data comes back within 12 hours. And the minimum object duration is different. With Glacier, it's 90 days. With Deep Archive, it's 180 days. So what we tell customers who are looking at Deep Archive first, before we take it any level deeper, is if you have applications or if you have data that has a retention requirement of 180 days or more, and your app can tolerate a 12-hour recall time, you should take a hard look at Deep Archive. There is cost-saving potential there for you. Okay? So that's Deep Archive, launched in the spring of 2019, less than a year old, and many customers are looking at this and talking to us about it and trying to understand how it fits into their overall storage strategy. So now I'm going to talk a little about S3 intelligent tiering. Traditionally, before intelligent tiering, how we would introduce storage classes is we would listen when customers told us that we didn't have just the right storage class for whatever workload they had coming at them. And as a result, we would go spec and build a new storage class. And what we kind of landed on over time, over a number of years, were sort of frequent access storage classes and infrequent access storage classes. So for frequently accessed data, which we consider any object that is fully read in a month to be frequently accessed, we have S3 standard, right? Tuned for frequent access, meant for sort of hot workloads, right? On the infrequent access side, we have two storage classes. We have standard infrequent access and one-zone infrequent access. Customers told us that data tends to start hot and cool off, and over time become very infrequently or never accessed. And so we built these two storage classes for these two different access patterns. And then we built tools that help customers to reason about which objects needed to go where, and a lifecycle engine that automates the movement or the transitioning of data across frequent and infrequent access tiers within S3. And this setup persisted for years and is deployed widely around the world by many, many customers, right? And many customers have realized significant cost savings by analyzing and then transitioning data to the appropriate tier according to the access patterns that that data faces. In this position, though, customers did start to come to us and say, hey, you guys are missing cases that I have. It doesn't fit into either one of these, and those access patterns are the ones that are changing or unknown. For example, if you have new apps coming online in your shop, or doing the work of analyzing your data and tiering it across storage classes, while is simple in S3, it's number 1001 on your long, long list of things to do. So you don't have a clear handle on what access patterns exist out across your entire enterprise, right? These cases where you just don't know, or those access patterns are going to change, that's why we introduced S3 intelligent tiering. And those are the cases where intelligent tiering really shines. And the reason why is because what S3 intelligent tiering does is it dynamically prices your storage based on the real access patterns on your data, right? So for your frequently accessed data, we charge you very similar to S3 standard. For infrequently accessed data, we charge you very similarly to our infrequent access storage classes. Here's how it works. So you put an object into S3 intelligent tiering exactly as you would into any other storage class. You can do it with an optional flag on the put, or you can lifecycle data into intelligent tiering from some other storage class. When you do that, objects will reside in the frequent access tier of intelligent tiering for 30 days. If an object is not accessed for 30 days, sitting in that frequent access tier, it's automatically tiered down to the infrequent access tier. And at that point, your pricing will dynamically switch, and you'll start to be billed an infrequent access storage price going forward. If then your app comes along and accesses that object, we'll automatically pop that object back into the frequent access tier, and the clock restarts. It'll sit there for 30 days again, and then again, if it's unaccessed, drop down to the infrequent access tier, and that cycle will repeat forever, right? As long as the data exists in S3. All right? Now, it's important to point out that your app doesn't know the difference, right? There is no performance difference. There's no performance difference for each of these two access tiers. This is a dynamic pricing exercise happening in the back end. There's not actually not actually data movement going on, right? Also, there's no operational overhead. There's nothing for you to do here. Once you put an object into intelligent tiering, it just automatically analyzes your access patterns and sort of makes the tiering happen for you. You don't have to do anything else from that point forward. And unlike our infrequent access tiers, storage classes, there's no recall fees here. There's no retrieval fees. So that act of bringing an object from the infrequent access tier to the frequent access tier is not something you're charged for. Instead, you pay a low per object monitoring fee across all the objects in intelligent tiering, and that gives you a very sort of predictable cost for the storage class. And we found, so that's intelligent tiering, and we found many, many customers evaluating this, learning about it over the course of 2019 since it was released, and many have taken advantage of it and seen significant cost savings as a result. Some of the important feedback that we've gotten from customers as they have kind of dug into intelligent tiering, basically went kind of like this, like, wow, you guys are doing really cool stuff with my access patterns here. You clearly understand like how each object is being accessed since you're tiering them this way. I want that information. I want to be able to do cool stuff based on real access patterns as well. And so our first step in this direction of providing you with more insight into access patterns down to the object level was an enhancement that we made in October of this year, so just a couple of months ago, to our S3 inventory reports. Now, if you're not familiar with S3 inventory reports, what they are is they're a nightly or weekly report that basically produces a full list of all the objects in your bucket. Along with just object names, like a list of objects, you also get interesting metadata about each one of those objects. So things like the create date, the retention time, whether it's encrypted, whether it's replicated, this sort of metadata. Most of what you can get from a head object call is in the inventory report. And customers throw it into Excel or into Athena and kind of slice and dice on it to better understand what's in their buckets. So we added this intelligent tiering access tier field to the inventory report. And what that allows you to do is it allows you to pop an inventory report into Excel or into Athena and run very simple queries against it to easily figure out which object in the bucket, which objects have not been accessed in 30 days, right? Because those are the objects now sitting in the infrequent access tier that you'll find in the inventory report, all right? It's a simple, subtle feature, but I talked to tons of customers about sort of how to reason about how their data is being accessed. And this simple feature in inventory reports actually solves a lot of problems that customers have about when they need to kind of drill down and understand how data is being accessed. So that's kind of my cost reduction section. Again, we talked about Deep Archive, which came out in the spring. We talked about S3 Intelligent Tiering, which came out in reInvent last year, but I included it in the What's New deck because it's been a big adoption curve for us this year, and we've also done a follow-on here with the access tiers and inventory reports. And that's sort of what's new in terms of storage classes and managing cost reduction in terms of storage cost. Now, on security and access, we have some big announcements here at reInvent this year. But before we get to those, I do want to talk for a minute about block public access, which was a big headline for us last year at reInvent. And this is another one of those features that has been important for us in 2019 in our conversations with customers. If you're not aware of what block public access is and what it does, it is that blunt instrument that allows you to apply blanket protection against overly permissive public sharing of your data. You can set block public access at the account or at the bucket level. and you can use it to just blanket block public access that's granted through bucket policies, through ACLs, or through both. And the consistent message that we give to customers, and we've given it since BPA came out at the end of last year, is that if you don't have workloads that specifically need internet-facing public access, you should turn block public access on at the account level. In fact, we recommend that if you have those workloads sort of sprinkled throughout your accounts, you localize those publicly facing workloads into dedicated accounts so that you can turn BPA on at the account level everywhere else. Account level block public access gets you the additional benefit of knowing for certain that any bucket that's created in that account has BPA enabled. There's no way around it, right? So we wanted to put this here in this presentation because we put it in most of our presentations throughout 2019 and make sure everyone's aware and understands sort of what BPA is. But we also put it here because we did a very significant follow-on to BPA that launched just here at reInvent just on Monday. And that feature is called Access Analyzer for S3. What Access Analyzer does, if BPA is that hammer that actually does the blocking, Access Analyzer is a reporting and analysis tool that is constantly chunking along in the background, analyzing access to your buckets and reporting out the state of sharing of your data in a very easily consumable way in the S3 console. You get drilled down into both public as well as buckets shared to other AWS accounts right in the S3 management console. Okay? So it's a super easy way to understand kind of the state of sharing for your data. I'm just going to take you through some of the stuff here in the UI to give you some texture on what features are sort of in Access Analyzer. So you see up top here, the top table with sort of multiple alarm bells here are your public access buckets, whether granted through ACL or through bucket policy. We give you the ability to archive any of those findings. If you have workloads or buckets in your account that are supposed to be public, we found that security people don't like it when we just throw alarms every single day. So being able to archive known public buckets to minimize the number of false positives that you see in console is a feature that exists. Also, in true Amazon fashion, we give you a one-click block capability, so a buy now capability for block public access, right? Where you can see the results and with a single click, block all public access on the buckets that we've surfaced. And then down below, I think this is a super cool feature that they added as well. This shows you sharing to specific AWS accounts. So if you've explicitly granted access to another AWS account, we don't consider that to be public access, right? You've allowed access to a specific stakeholder. And so the ability to kind of step back and get that total list of all of the sharing with other AWS accounts that exist within a region is, I think, a super useful thing for customers to kind of have at their fingertips. We see more and more this sort of interconnected data exchange going on between S3 buckets. And so being able to automate the auditing and reasoning about what sharing exists is a super cool add, I think, for the S3 management console. All right, so that's Access Analyzer. Again, we announced this on Monday morning here at reInvent, something we're super excited to get into your hands to start to play with and work with. All right, so the next one that I'm going to talk about is called Amazon S3 Access Points. And this was a big announcement for us here at the show. We announced it on Tuesday in the keynote. And it's a big new add for S3. We think it'll have architectural implications for years to come, the introduction of access points for S3. What they effectively are, they decouple the endpoint concept from the bucket and allow you to stand up multiple endpoints on top of an S3 bucket. Okay? Each one of those endpoints comes with its own set of access controls, its own name, and can be vended out to as many stakeholders in the environment as you need to support. Okay, so at a high level, that's what it physically is, a new resource within S3 for managing access at scale. There are sort of three use cases or three problems that we think it solves for customers. The first is that it's intended, the access points are intended to simplify the management of shared buckets. So if you have many stakeholders in the environment, all coming in to access data within a single bucket, which is a pattern that we see a lot, being able to vend out a dedicated endpoint to each one of those actors in the environment that has its own permissions, that has its own access rules on it, and that is effectively ephemeral, can be stood up and taken down separate from the storage itself, is extremely useful. And we'll talk a little bit about an example here in just a moment. We also took the opportunity to establish a new namespace to prevent naming conflicts. So consistent feedback that we've gotten from customers on S3 is, for some use cases, there's a frustration with the requirement that you must have a globally unique name for your buckets. And since we're sort of in there introducing new naming schemes, we took the opportunity to relieve that requirement. And I'll talk a little bit about how we allow you to have any name that you choose with access points. And the last piece is the ability to restrict network traffic to specific VPCs. So for workloads that are running on EC2 in VPCs, access points give additional controls to kind of lock up to specific VPCs, so you can more easily kind of lock down the data path between your clients running on EC2 and your data sitting in S3. So I'll drill down a little bit into each one of these three to give you some more context on kind of what we mean and how we envision them being used. So on the S3 team, we talk to customers every single day about data lakes. This is a hot topic here at the show, and I'm sure many of you are thinking about data lakes and building them yourselves. And as more and more customers have built out data lakes and expanded them, we kind of have often seen this sort of pattern, right? This is sort of a simplified version of the pattern that we commonly see, where many data sources within the enterprise, such as databases, data warehouses, ERP, CRM systems, and even third-party apps that are coming in from outside, they're all being piped in to a single bucket that stores the data lake. And this is an effective way to do it, to localize your data and to run analysis. But a problem that customers have begun to face as these environments have gotten bigger and wider, and we had more stakeholders dumping data into a single bucket with more systems doing that dumping, is that all of these systems, all of these data paths basically bottleneck at the single bucket name and the single bucket policy, right? It is certainly doable. But when you're set up in this way, that single bucket policy, getting it wrong, fat fingering that policy if you want to change it, has a huge blast radius. It breaks everybody if you get your bucket policy wrong, right? And as customers stand up more and more sort of real-time processes off of their data lakes, they're starting to look at this setup and saying, that's a bit of an availability risk for me, that an operator can come in and muck up a bucket policy and take down everybody's access to the data lake. Okay? So what access points do is they allow us to decouple that sort of entry point to the bucket and to manage them a specific entry point for every data path coming in, or groups of data paths coming in, and to assign a policy to each one of those access points. So in this sort of simplified example here, here's a case where we have 5 access points, each one dedicated to a specific data path into the bucket, each one with a policy that restricts that set of clients into either a prefix or to a set of tags on objects within the bucket. So we can carve up the bucket, grant access on an access point by access point basis. And now if I go mess up one of these access point policies, the blast radius is much smaller, right? It's 1/5. I'll take down the data path that I'm in there messing with and not all access to the bucket. Also, since they're ephemeral, and they can be disposed of. If you grant access to your bucket to a vendor, for example, and they're getting and putting data to and from your data lake, and you decide that, hey, we're not doing business with this vendor anymore, you can just remove the access point. From the perspective of those clients, the bucket is gone. Everything that they knew about the bucket, right, which is the name, now no longer exists, right? And you've made no changes to the underlying storage. So this is what we mean when we say that we think that there are architectural implications for years to come with access points. It's because of that decoupling of the storage from the access layer. It's almost like a virtualization concept where I can stand up and tear down the routes in to my data lake, to my shared data sets. Let's talk a little bit about naming. So the naming is different. It'll be something to get used to, but it makes sense, and I'll just walk you through it and let you know how it kind of works and why we went down this path. So you name an access point the same way that you always have, right? You give it a DNS compliant string, and what S3 will do, it will automatically append your AWS account ID to the name, right? This isn't an option. S3 automatically does that, and it places that name in a new subdomain called S3-access point, okay? What this means is that now that sort of namespace, that access point namespace, has a gatekeeper in front of it, which is S3. And since we always append an account ID, it means whatever name you give your access point, if you name it test, or if you name it my AP, that name will be available as long as you haven't already consumed it within your account, right? So we could all go home and create an access point called test, right? I think that if we all went home and tried to create a bucket named test, it would not work, right? So that new subdomain coupled with the concatenation of account ID plus the string that you give means that you have total freedom within an account to name your stuff, your access points, whatever you want. Also, access points are inherently regional, right? So every time you create one, it goes into a region, and there is no global namespace for access points like there is for the underlying buckets, which means you can create an access point called test in every single region around the world. Because access points are not only account unique, but they're regional unique as well. Okay, so this unlocks a lot of flexibility from a naming perspective. It allows you to reuse the same name in multiple regions, which gives you a code simplification benefit if you want to spin batch jobs against a test bucket in multiple regions. You're guaranteed to get the name that you want, so no kind of playing around, trying to come up with a naming scheme that is going to guarantee availability in the global namespace. And you can create up to 1,000 access points per account, which gives you significantly more names when you add in the number of buckets that you also have according to service limits. Okay? So that's the naming part. I think it gets around a few sort of long-standing requests that customers have had on flexibility of naming, especially for sort of private access scenarios. The last thing that I want to talk about is the ability to bind to a VPC. So there's a parameter on access points called network origin. And when you stand up an access point, you can specify a VPC or a list of VPCs that you want to bind to. And that restricts traffic, network traffic, through that access point to only those VPCs. So this is another way not only to block public access, but to go further and to narrow down the available possible data paths through which data can traverse to your bucket. Not only that, but access points have unlike buckets, access points have a full ARN that has the region and your account ID in the ARN of the access point, which means you can write a VPC endpoint policy on the other side that locks the VPC endpoint to any access point within your account, because now you can match against the account ID in the ARN of the access point. So, all up, these sort of configuration options from a networking perspective allow you to bind and enforce the allowable data paths from both directions, from VPC into S3 and from S3 up to VPC. And this is stuff that you can do today, but it requires sort of bucket by bucket whitelisting. It's significantly more complex than just standing up an access point that is dedicated to a certain set of VPCs in your environment. Okay? So again, those are the three big features of access points at launch. We envision them for being stood up for shared data sets. You can create many and dictate specific access rules for specific actors within your environment. We have this VPC binding configuration that you can implement, as well as the new naming standard, which allows you to implement not being stopped by some of the naming restrictions that customers have faced in the past. All up, this is kind of how we envision it being used. You would segment your clients into distinct groups, vend out an access point to each one of those distinct groups, apply a policy to each access point so that you can tailor the permissions for each one of those stakeholders, while all the while maintaining a central set of rules and policies to manage the data itself that lives underneath. So one replication policy, one lifecycle policy, one encryption policy, all of that stuff that is typically associated with compliance, you manage that in one place. Just to give you a view for how it looks in the UI, there's a new tab on the buckets page, and it lists out all the access points that are associated with that bucket. And you can also you can access your data through an access point in the UI. So you can pop into sort of access point mode here, and that'll allow you to visualize sort of what your clients will see as they're coming through the access point that you created into your data. All right? So that's access points. We are really excited to hand that over to you guys. I think that there's a lot to build with access points, and it is architecturally significant for customers using S3 going forward. So that's my security and access section. Again, we talked about block public access, as well as the follow-on that we did for block public access, launched here at the show, called S3 Access Analyzer. And we talked about access points, a brand new resource type in S3. Okay, so now I'm going to talk about data management. And I have 4 features to talk to you about in the data management section. The first thing that I want to talk about is batch operations. Now, batch operations is one of my favorite features in S3 because I think that this is just an area where cloud storage just really shines, right? It just wouldn't be feasible in an on-prem storage array to implement a fully fledged batch processing system, right? It would be too expensive, it would be too heavyweight. It would just make so much more sense to have a standalone stack sitting next to the array. But with cloud storage, it's possible. And we did it. We implemented such a batch processing system because customers were telling us that it was common for them to need to do something 1,000 or 1,000,000 or 1,000,000,000 times against a large group of objects, and pulling all those objects out into EC2, running a simple transform and putting them back into S3 was just too cumbersome and required them to actually write code at scale. So we implemented batch operations that does the heavy lifting for you whenever you need to do something 1,000,000 times. Batch operations can replace tags on your objects. It can change access controls. It can restore objects from Glacier. It can copy objects. Or if you need to do something that doesn't fit into one of those 4 categories, it can run a Lambda against all of your objects. All right? So a super cool, useful feature if you ever need to do something 1,000,000 times, because that is always hard. The best way to really talk about it, to give detail about what it does, is to just kind of show you what is in the UI. So this is the batch operations UI in S3, in the S3 management console. And if you've ever used a batch processing system, it is that, right? You get a list of all the jobs that you've run or are running. Right? It shows you what did you do with your data. So in this case, I've run a bunch of jobs that have replaced tags and done put copies. It tells you the status of all of the jobs. Did they succeed? Did they fail? Are they in the process of completing? And it shows you how successful those jobs were on a percentage basis. And like I mentioned, it's easy to write a for loop in a shell script. I'm a product manager and I can do that, right? But it's hard to ensure that you have a fully consistent 100% completion rate against a million objects, right? And so the success rate as well as the completion reports that batch operations give you allow you to go clean up those 3 objects out of a million that had the wrong permissions, which is the case here, so that you can go true it up and ensure that you have the consistent result that you were looking for from the batch job, right? So that's batch operations. Great for big ad hoc operations that you need to do. You need to copy a million objects or tag a million objects. We always recommend that you use batch operations so that you're not writing code for retries and throttling back-offs and all the stuff that you need to take care of just to get a 100% correct result at the end. Another little feature that we announced in July was an enhancement to the metrics that we provide on S3 in CloudWatch. So internally, the way that we manage the large distributed system that is S3, we use CloudWatch metrics heavily, and our operators don't focus on min, max, and average, which is what we had in CloudWatch before. When we think about the performance of S3, we think about it in terms of percentiles. So a max first byte latency across a million results or a million requests is certainly interesting, but it doesn't give you a very, say, textured picture of the actual performance of your app, right? So CloudWatch percentiles allow you to see the 99th percentile, the 99.9th percentile. And so you just get that texture. You can have a much better understanding of what your clients are actually seeing from S3 across all of your requests, right? So again, this is how we manage the service, and many customers were asking us over time to give that additional visibility as well. So that launched in July. Okay, so I have one more topic that I'm going to talk to you about, and then we'll just take questions off to the side because I have no idea how to do questions with the headphones on. And I'm going to talk about replication, right? So this is what we had on replication when we all got together last year in 2018 at reInvent. We had the ability to replicate from a bucket in one region to a bucket in another. And many customers taking advantage of this feature. And I've called on a bunch of customers using it because we had all these other customer asks on replication. And many customers were just sort of like, yeah, I turned that on 4 years ago and it's fine. I don't know, it works. And it's been that sort of feature for us, that sort of just works feature. But as applications in the cloud mature and as more sort of enterprise, higher end applications come into AWS, many customers have asked us for those sort of enterprise grade replication features that help to achieve sort of compliance requirements for multi-site replication. And so we made 3 big changes to replication over the course of the last year. One thing that we did is we added the ability to do same region replication. So instead of having to replicate from a bucket in one region to a bucket in another, you can now replicate between any 2 buckets, even if they're in the same region. And there are some cool use cases for this that I'll talk to in just a moment. We also gave the ability to replicate retention controls. So if you're using S3 object lock to enforce delete protection or to enforce retention periods, CRR now, or S3 replication now has the ability to maintain synchronization across 2 copies of an object in terms of its retention period. So you can apply legal holds, and those legal holds will then replicate. You can remove legal holds, and the removal of the legal hold will then also replicate. So it keeps sort of the metadata in sync across both sides. And then a couple of weeks ago, in sort of the pre-invent time frame, we launched replication time control, which is a huge enhancement to our replication capability, something that I'm super excited about. And it gives you predictable replication, backed by an SLA with metrics to prove it. Okay? So I'm going to talk about these three in a little bit more depth, and then we'll close it out. So same region replication is straightforward. It does what S3 replication does, just within a region. You can apply a same region replication rule to the whole bucket or to a prefix or to a set of object tags, and it automatically protects every single version of every single object that rule matches from that point forward. Okay? But S3 replication does more than just make copies of your objects. You can also do some transforms on the replica as well. Specifically, you can change ownership and go cross-account on the replica, right? So if you want to replicate into a second account that is locked down and change the ownership of the objects to the bucket owner in that second account, you can do that automatically with CRR. And it's an awesome fit with same region replication, because if you don't have those compliance requirements that require geographic distance between replica, and you just want an easy way to back up all your stuff, squirreling a second copy away in a second sort of locked down account is a pretty effective kind of set and forget way to do that. Also, you can do storage class switching. So if you're just squirreling away that sort of copy of last resort to protect against, account compromise scenarios or bad actor scenarios, replicating to Glacier Deep Archive, for example, in the same account, so no cross-region fees, just automatically, always happening in the background. It's a really easy and effective way to build that sort of virtual air gap for your data. That's the kind of primary use case that we hear from customers, that sort of bad actor and account compromise scenario. You can also apply object lock on that virtual air-gapped copy, so that you're in a second account, you've changed the ownership on the objects, you've got object lock applied, which will block deletes altogether, and you're sitting on an archive storage class. All of that sort of stacks into one kind of cool automatic backup solution. There's also a log aggregation use case that we hear from customers a lot, where you have applications running against a bunch of buckets in the region, in the account, and you want to run one of these big log analysis tools against that log data. A lot of times you can simplify that architecture significantly by just taking advantage of the automatic nature of S3 replication to aggregate that data set from many buckets down to just one place where you can just pound on that single bucket with your analytics processes. So that's same region replication, kind of why customers asked us to do it, and we're excited to have that out. This came out in late summer, early fall. So this is in the S3 Management Console today as well. All right, retention control replication. I think I've talked about this already. Again, this is all about synchronizing retention periods across source and target, right? It's kind of hard because this is not object replication so much as it's metadata replication, right? It gives you the ability to, for example, if I have a retention period applied on one side, if I then extend it by 10 years, S3 replication will now replicate that extension without creating a new copy or pumping, the full size of the object over the network to the destination region. So if you're using object lock either in compliance or just data protection scenarios for delete protection, this is a cool way to manage retention periods and keep them in sync across multiple regions. All right. So my last topic before I sum it all up, it's a new feature in S3 replication called replication time control. Replication time control brings predictability to the replication process, right? You get very predictable replication times from RTC, so predictable that we back them with an AWS SLA, the first SLA of its kind in the industry. Beyond just an assurance and a contract that says that we'll replicate within a certain window, we give you the CloudWatch metrics to prove it. So you can go back at the bucket level, at the replication rule level. If you've got a replication rule applied to a set of object tags, you can go down to the object tag level and reason about how your replication is doing. You have that visibility with replication time control. So there's a guy named Mo on my team, and he was the product manager who was working on this feature that they just launched now 2 weeks ago. And we launched on November 20th, and he was at home when they launched, and he showed his laptops. He was really super excited to his wife, right? And he's like, look what we built. This is so awesome. This is what I've been working so hard on, nights and weekends. And he showed her the feature, and she looked at it, and it's like one checkbox in the UI. And she's like, all right, dude. But behind the scenes, we made significant improvements to the replication system to the point where we can place an SLA on S3 replication that says that we will replicate all objects, or 99.9% of all objects replicated within 15 minutes. And for us at AWS, an SLA is a huge deal. We value your trust so much, so for us to come out and provide sort of hard numbers with an SLA is a big deal for us. And it's the first new SLA on S3 in some time, right? And so we're super proud of this, and we think it'll make a big difference for customers who have those very specific compliance requirements around how long it can take, is tolerable for asynchronous replication to complete. But I think the real gem of the release is the metrics. I just think they are super, super cool. There are 3 new metrics that come with replication time control. The first 2, bytes pending and operations pending, they give you visibility into your replication queue depth. So you can see how much storage is outstanding yet to replicate. Same thing with bytes. So you can see or same thing with operations. Operations are basically how many objects you have left to replicate. We call it operations instead of objects, sort of back to the replication or the retention time replication, right? So that may be metadata that you're replicating. So we call them operations. But the last one, replication latency, that's a measurement that's taken in time, and that shows you the age of your replica on the target side, right? It's your oldest unreplicated object. For those of you who are longtime backup and recovery nerds like me, that would be your recovery point objective. So that is the P100 point at which all of your data is complete and replicated on the target side. And since it's a CloudWatch metric, now you can take that information, your achieved recovery point, right? And you can alarm on it. You can report on it to read back to the business who's putting these sort of requirements, these compliance requirements on you. You can read back to the business and say, yes, I am making my 5-minute RPO or my 15-minute RPO or my whatever the RPO is, you know it now. You can report it back. You can prove it beyond just our assurance with an SLA. Also, many customers ask for this feature so that they know when their data is complete on the target side so that they can do failover, right? Often it's not just, or almost always, it's not just S3, it's databases and it's Dynamo, and it all has to come up together at a synchronized point in time that you're recovering to. And having this granular sort of metric that tells you that, yeah, my data is current on the replica side as of 3 minutes ago, allows you to bring up your whole app as of 3 minutes ago so that you come up in a healthy state with all of the pieces matching that single recovery point, okay? So I don't know, I've been doing data protection for a long time. I love this feature. I think it's so cool that we're able to sort of top to bottom network storage everything, be able to come in with an SLA and provide just a simple set of metrics that allows you to know exactly where you are on your replication. On top of that, and I always forget this slide and then I forget, oh yeah, there's one more cool thing that hopefully you'll never know about. Hopefully you'll never use this feature, but if we actually were to breach, right? If we actually were to take longer than 15 minutes, not only would you see that in the aggregate in your metrics that we talked about on the previous slide, but every single object that breaches will throw an event. So an object sits on the target side unreplicated for 15 minutes, we'll throw an event. That'll give you a list of all the objects that breached, how big they are, what time they breached, all that stuff. Then we'll also throw in a second event when those breached objects actually do finish replication, so you know when they come back into compliance. Okay? So you get the predictability by the underlying changes that we made to the replication system. You get the SLA that you can show back to the business and say, look, AWS stands by this replication performance. You get the metrics to prove it in the aggregate, right? So you know how you're doing, you know your P100 recovery point on the target side to be used in failover, and you can drill down to the individual object to know, to reason about which objects have breached if that were ever to happen. And that's our pitch. That's my pitch. 10 features launched over the course since last reInvent, some here at the show, some sprinkled throughout the year. Made big improvements on cost reduction, 2 big storage classes since we all last got together, a follow-on on intelligent tiering by adding the access tier information into inventory reports. Big announcements here at the show on security and access. Following on our block public access release, with S3 Access Analyzer and S3 Access Points, again, kind of fundamentally, we think fundamentally changes the way that access to S3 will occur over the long run. And then big changes in the data management space with batch operations, a brand new batch processing system on board built into S3, more granular metrics in terms of percentiles on CloudWatch, and then huge changes to the replication system, something that we're very excited to get into your hands. So I have about 8 minutes left. I'll use that for questions, and we'll just kind of go off to the side here. But I really appreciate y'all taking an hour and giving me an hour of your reInvent. We're almost there, everybody. We're almost to the party. Again, my name is Paul Megan. You can find me on Twitter if you want to get in touch with me, or I'll give you a card off to the side. And please give feedback and rate me. So thank you very much.